Okay, this is our last section in Chapter 8. And this is 8.5, Solving More Difficult Trigonometric Equations. And then, when I see more difficult, I kind of laugh out loud. Sorry, extra click there, because, they're trigonometric equations, all right? So if you can solve an algebraic equation, you can do the first steps in solving a trigonometric equation. And then solve for the angle. That's just Chapter 7, which you guys are experts at. So really more difficult, they're all pretty easy. Now I will admit, sometimes they'll give you a trigonometric equation with extra trig functions in there, so you're going to have some strategies like convert to one trig function or divide both sides by one of the trig functions, and you have to be careful there. But we'll address that when we get to them today. Okay, it's a really great lesson, so take great notes and ask questions, and let's have a lot of fun here. So today's objective will be to use trigonometric identities or technology to solve more difficult trigonometric equations. And honestly, if you can't solve a trigonometric identity by hand, all right, you can use your calculator and get really good approximations. So here's our first problem right here. Solve 2 sine squared of theta minus 1 equals 0. All right, so your first objective here would be, well, we'd better solve for sine squared right there. Okay, so what are we going to do then? Well, let's do 2 steps in one right here. The first thing I would do is add 1 to both sides and then divide by 2. So doesn't that imply sine squared of theta would have to equal 1/2? All right, now you've got to undo this square right here. Let's solve for sine of theta. So let's simply take the square root of both sides. So the square root of sine squared of theta would simply be sine of theta. And when I take the square root of 1/2, I have to talk about both the positive and the negative roots. So we need a plus or minus. And you guys know the square root of 1/2. We're not going to write that the square root of 1/2 because that's the square root of 1 over the square root of 2, and we must rationalize the denominator. So we're going to write the square root of 1/2 as the square root of 2 over 2. So there's the first major part right there. Sine of theta equals plus or minus the square root of 2 over 2. Now, you all have the unit circle mastered, and you can tell me when sine has an output of positive root 2 over 2 or negative root 2 over 2. So let's get there. What does theta equal? And the beauty of doing this by hand would be we're going to have exact answers. So let's take a look at our unit circle. All right. Now, remember quadrant 1 and all of your reference angles and the angle pi over 4. Now, at pi over 4, isn't this vertical distance right here exactly root 2 over 2? And what mode am I in? I'm in degrees right here. So that would be a 45-degree angle right there. All right, now you think to yourself, in what other quadrant is sine positive? And that would be quadrant 2. So let's reflect this terminal ray in the y-axis to get this terminal ray. And how many degrees would that be? Well, 45 degrees, 90 degrees, that's 135 degrees right there. Okay, so there's our 2 positive root 2 over 2's. And now how about the negative root 2 over 2's? Well, let's go to quadrant 3. You see this terminal ray right here? Isn't this vertical distance right there going to be with direction negative root 2 over 2? So what's that angle? All right, well, I would just take 45 degrees and 180, add 180 to that, and isn't that 225 degrees? And then you have your quadrant 4 angle right here, where this vertical distance right here is also root 2 over 2, but it's negative. So what is that angle? So, and again, how you get that is your business. You could go 360 minus 45, something like that. All right, so what would that be? 360 minus 45? Is that 315 degrees? Why, I believe so. And there are my 4 angles right there in the half open interval from 0 to 360, and that's our first problem. Simple as that. So it's like solving an algebraic equation, and then you finish it up with some really cool trigonometry. Okay, now solve x squared minus 3x minus 4. All right, now why did I put this here? Because we're talking about trigonometric equations, aren't we? This is a quadratic equation. And you know, to solve quadratic equations, if you can factor it, you do. So this is some practice for you. Let's factor. All right, so let's see. X squared, well, won't my first term in each binomial have to be x? And then I need two numbers whose product is -4 and whose sum is -3. So I believe I would use what? A -4 and a +1. There we go. We have just factored x squared minus 3x minus 4, and x squared minus 3x minus 4 could only equal 0 if one of these two factors were equal to 0. And that's the zero product property of algebra right there. So that implies x could equal, well, what number plus 1 is 0? That's a -1. And what number minus 4 is 0? A +4. Now, let's do that with the trigonometric equation. So now I'm going to give you the trigonometric equation. Cos squared theta minus 3 cosine of theta minus 4 equals 0. Now, do you notice? X squared minus 3x minus 4, cos squared minus 3 cos minus 4. Let's factor this the same way we factored the quadratic, because this is a trigonometric function in quadratic form. So let's factor. So I need cos squared of theta. That means I'm going to have a cosine of theta times a cosine of theta. And then same thing, I need two numbers whose product is -4. So that, and then whose sum is -3. So I'm going to do the same, -4 plus 1. And now by the zero product property of algebra, cosine could equal two numbers here. Cosine of theta could equal, well, cosine of theta plus 1 would have to be 0, so that means cosine could be -1 or +4, just like above. All right, and then remember cosine. What's the range of cosine? Cosine oscillates between -1 and +1, so this 4 is not an option. So I'm down to cosine of theta has to equal -1. And there is only one angle within one rotation of the unit circle where cosine of theta equals -1. And that's a quadrantal angle right here. And wouldn't cosine equal -1 at this terminal ray right there? See that terminal point right there? Well, this distance with direction is -1. So what is that angle? And, you know, they didn't give us any kind of mode right here. They just said solve it. So your answer could be in radians or degrees. So change it up. Let's go degrees. Well, wouldn't this angle right here be 180 degrees? There you go. Now, most of you think you're done right now, except I don't see any, half open interval from 0 to 360 degrees right here. So that implies I need all possible angles theta for which this equation would be true. So think about that now. Okay, there was not a given interval, so we better find all solutions. And that means my answer is going to be theta equals 180 degrees plus any multiple of 360 degrees. Because again, we can go in either direction, and if we do a complete rotation, as long as we end up on that same terminal ray, we're going to have the same output of 180 degrees. So let's just go plus n times 360 degrees. And that n is any possible integer, all right? So that means I'm going either clockwise in a positive direction, or I could be going in a negative direction. It doesn't matter. That n times 360 handles any possible solution if we add it to the 180. Okay, now, oh, look at this one. Maybe they are getting a little more difficult because you see we have sine squared, sine, and cos squared. So if I'm solving a trigonometric equation, I would like to have everything in terms of one trig function, either sine or cosine, preferably. Okay? So, can I write cos squared in terms of sine? Well, let's think. What about our Pythagorean relationships? So some problems that are not quadratic can be converted to quadratic form. All right? And this is more like a conic form right here because my sine's being squared and my cosine is being squared. So I'm going to do this. Sine squared of x minus sine of x equals, and now I'm going to take this cos squared of x, and I'm going to use my Pythagorean relationships right here. And notice my favorite one. Sine squared of theta plus cos squared of theta equals 1. So doesn't that imply cos squared of theta could equal 1 minus sine squared of theta? Now, everything's in terms of sine, and I can put this trigonometric function in terms of sine in quadratic form now. So let's get everything to one side. So I think I'm going to add sine squared to both sides, and I already have one sine squared on the left, so now I have two sine squareds on the left. Minus the sine of x, and see the 1 on the right? We better subtract that to get 0 on the right, so that would be a minus 1. And now my trigonometric equation is in one variable and it's in quadratic form, and I can factor this just like I factored the problem on the previous slide. So 2 sine squared of x, can I go 2 sine of x and sine of x? And then I need two numbers whose product is -1 and whose sum is, well, we got to deal with this 2 as well, so let's process this one a little more. Wouldn't that mean the product of -1, would I have to put the 1 here and the -1 here? And do you see why? Because if I FOIL that, 2 sine x times -1 is -2 sine x, and sine x times +1 is sine of x, and if you add those together, you get your negative sine x right there. Okay, so now zero product property of algebra again. One of these two factors would have to be 0. So that's going to imply, well, 2 times sine of x plus 1 equals 0 would imply sine of x would be a -1/2. Okay, or sine of x minus 1 equals 0 implies sine of x would have to equal a 1. All right, and there's my two possible answers right there, solving for sine of x, and now we have to solve for the angle x. So, when does sine of x have an output of -1/2? You know, I'm going to bring out my unit circle again. And -1/2, that means I have to be in quadrant 3. All right. And that would be, the reference angle here would be pi over 6. So how many pi over 6s would it take me to get right there? That'd be 6 pi over 6 and one more pi over 6. That's a 7 pi over 6. And then sine is also negative in quadrant 4, so let's reflect this terminal ray in the y-axis to get that one. And how many pi over 6s is this angle? Well, that would be 1 rotation minus a pi over 6. So isn't that going to be 11 pi over 6? Look at that. Okay, there's my two angles in which sine of x equals -1/2. And now, when does sine of x equal 1? Well, that's the quadrantal angle right there. This vertical distance right here is 1, and that's simply pi over 2. So there's my three solutions right there. X can either be 7 pi over 6, 11 pi over 6, or pi over 2. Okay, Well, looking pretty easy so far. All right. Ooh, look at what they're doing here. Solve sine of x times tangent of x equals 3 times sine of x in the half open interval from 0 to 2 pi and give answers to the nearest hundredth of a radian. That tells me we're going to be using some calculator on this one a little bit. Okay, so notice here we have two trig functions, sine and tangent, all right, but nothing's being squared here, so I probably don't want to use any Pythagorean relationships. So let's think about this. Could I get everything on one side and then factor out a common factor? Well, first, let's take a look. Sine of x times tangent of x minus 3 sine of x equals 0. So I hope you see the first step. And now I have a common factor of sine. Let's factor that out. Since we can't write the equation in terms of one function, factor or write everything in terms of sine and cosine. And this is factorable, so we're going to factor it. So let's factor sine of x out. And that would give me my first term in the parenthesis would be tangent of x. And my second term would be a minus 3. There we go. Now it's factored. And now again, by the zero product property of algebra, sine of x would either have to equal 0 or tangent of x, well, what number minus 3 is 0? Tangent of x could equal 3. Okay, so I've solved for my trig functions. Now let's solve for our angles x. So when does sine have an output of 0? Well, those would be quadrantal angles. And sine has an output of 0 at this terminal ray right there, because there's no vertical distance there. And let me see, they said give answers to the nearest hundredth of a radian. So if this is 0 radians right here, I'm going to write that as 0.00. Okay, and then over here at pi radians, and pi, I'd prefer pi personally, but they want it to the nearest hundredth of a radian, so isn't pi 3.14? And that handles when sine of x equals 0 in this half open interval right here. So now, tangent of x equals 3. Well, we would have to solve for that x, so we're going to inverse tangent both sides. So that means x would approximately be, and I hope you see that, inverse tangent of x is x, and that would have to equal inverse tangent of 3. Oh, and I didn't even write it out. I'm sorry, you guys. So let's punch out inverse tangent of 3. And first, make sure your calculator is in radian mode. I'm in degrees, so I'm going to change that to radians. And then let's go ahead and punch out inverse tangent of 3. Second tangent, there's my inverse tangent of what again? Of 3. And that is 1.249045772. And to the nearest hundredth of a radian, that would be 1.25. So there we go. So 1.25, if you want to see it in the unit circle, that's going to be over here somewhere in quadrant 1 because pi over 2 is 1.57 approximately. So about right there. Okay, now, is there another quadrant in which tangent is positive? Well, remember, tangent is sine over cosine. So that means sine and cosine would have to have the same sign. And isn't sine and cosine, aren't they both negative in quadrant 3? So I'm going to take this terminal ray and I'm going to rotate it pi radians to get that terminal ray right there. Now, what's the measure of this angle? Well, wouldn't that be what? My last answer, 1.25 plus a pi. 1.25, that's this angle. And then add pi to that, and there I am at this angle right there. And let's punch that out. 1.25 plus pi. I'm going to go second answer, my last answer, plus second pi. And I am getting 4.39. 4.39 radians. There we go. And that is, did we cover everything there? That's every possibility right there. So we've got 0.00, 3.14, 1.25, and 4.39. Awesome problems. Okay. Okay, this one now, kind of like the last one, we have two trig functions, except this time we have sine and cosine. And there's going to be a real easy way to take care of this. Now, on the last one, remember, we got everything to the left, and then we factored out the prime or the common factor of both terms. All right, and then use zero product property. Now, on a problem like this, all right, could I divide both sides of this by sine of theta? Now, you've got to be careful when you're solving an equation and you're dividing by an expression with your variable in it, because that can introduce, you could lose roots that way, all right? But all I have to think about this, if I'm thinking about dividing by sine of theta, all I have to worry about is when sine of theta equals 0, could that be a possible solution to this equation? All right, and 2 sine of theta is not going to equal cosine of theta when sine of theta equals 0. So I can do this. So 2 sine of theta equals cosine of theta, and I can divide by sine of theta as long as sine of theta does not equal 0. So let's divide both sides by sine. So 2 sine of theta divided by sine of theta would be 2. And cosine of theta divided by sine of theta, that would be cotangent of theta. Now, I don't have a cotangent button or an inverse cotangent button on my calculator. So I'm going to have to rewrite this statement right here. And I'm going to do that with my reciprocal relationships. Because isn't cotangent of theta 1 over tangent of theta? You see that right here. So how about we do this? All right, let's rewrite with reciprocals. Let's just take the reciprocal of both sides, actually. All right, so I got an equal right here. And what's the reciprocal of 2? It is 1/2. What is the reciprocal of cotangent? That would be tangent of theta. There you go. Okay, so does everybody see, because we don't have an inverse cotangent on our calculator, all right, we're going to have to rewrite this statement by simply taking the reciprocal of both sides. All right, now I can solve for theta because I can go inverse tangent of both sides. So that means theta is going to equal the inverse tangent of 1/2. And now, what mode do I need to be in? Look at the interval above. That half open interval is in degrees. So let's double check, because I can't remember where we were last time. And I'm in radians right now, so I'm going to convert to degrees. And then I'm going to punch out inverse tangent of 1/2. Second, inverse tangent of 1 divided by 2. And I'm getting 26.56505,118. And did they tell me what to round to? I don't believe they did. So as long as you round this correctly, I'd have to give you full credit. So let's see. 26.57. Yeah, that works for me. And let's go ahead and put that into our unit circle over here. 26.57. I don't know. Something like that right there. That's not perfect, but it's ballpark. And I want this unit circle right here, because then in what other quadrant can tangent be positive? And again, tangent is sine over cosine. So that means I'm going to have a quadrant 3 angle where sine and cosine are both negative, and a negative over a negative is positive. So I'm going to take this terminal ray and I'm going to rotate it 180 degrees to get that terminal ray right there. And isn't that nothing more than this 26.57? But then I've got to add 180 to that, and that's going to give me, let's just go second answer plus 180, second answer plus 180, and I'm getting 206 point, what did I go, 100? Yeah, 206.57. Oh, and I rounded this one to the nearest tenth. So 206.6 degrees. Now, I can get away with that because nobody told me what I needed to round to. Okay. Typically, I like to be consistent with my answers. All right. But anyway, there we go. 206.6. Now, let's make sure we've covered everything there. Yeah, we have. There's my two solutions. Beautiful. Okay. Oh, my. Now, take a look at the last one where we had 2 sine of theta equals cosine of theta, and we simply divided both sides by sine. Here is almost the same equation, but they added this little +1 right there. So that means I can't just run around dividing by sine or cosine, or I'm going to have trig functions all over the place. All right, so what are we going to do here? Well, I think we're going to have to probably write everything in terms of cosine. So see the sine of theta? How can I write sine of theta in terms of cosine? Well, I have my Pythagorean relationships, so we can rewrite the equations so there's only one function, and that function I want to use cosine with my Pythagorean relationships. Now, do you see the sine squared theta plus cos squared theta equals 1? All right, that tells me that sine squared would be 1 minus cos squared. So if sine squared theta equals 1 minus cos squared theta, then what's sine of theta? All right, well, let's just square root both sides. So that implies if I take the square root of sine squared of theta, I get sine of theta. And now over here on the right, I have to talk about the positive and the negative root. So there's my plus or minus, and then just the square root of the two terms, 1 minus cos squared of theta. All right, so guess what? Sine of theta equals plus or minus the square root of 1 minus cos squared theta. So it's going to get a little ugly for a second, but I'm going to substitute that plus minus the radical for the sine of theta. So I get 2 times, instead of sine of theta, I'm going to put plus or minus this radical in there, equals cosine of theta plus 1. Now, I've got to solve for cosine. So the first thing I want to do is get rid of this radical. And how do we get rid of a square root? Well, we'd square both sides. So let's square each factor on the left. 2 squared would be 4, and then when I square this plus or minus the radical, I can drop the plus or minus and the radical to get the quantity 1 minus cos squared of theta, and that has to equal the right-hand side. Okay, excuse me, the right-hand side, and I better square it. So if I square cosine of theta plus 1, all right, I'm going to get cosine times cosine is cos squared theta. And then let's do the outside and the inside. So I have 1 cos theta plus another cos theta. That's plus 2 cos theta. And then 1 times 1 plus 1. So I just squared cosine of theta plus 1 right there. All right. Now, let's distribute the 4 and get this into quadratic form. All right, so 4 times 1 is 4, and 4 times negative cos squared theta would be negative 4 cos squared theta. So to get this into quadratic form now, let's get everything, which direction are we going to need to go? We're going to need to go to the right. So let's put a 0 on the left, and let's add 4 cos squared theta to both sides. That would give me 5 cos squared thetas. And then I have the plus 2 cosine of theta. All right. And then I've got to get rid of this 4. Let's subtract 4 from the 1 to get minus 3. Now, I am hoping we now have a trigonometric equation in quadratic form. And let's hope this is factorable. Otherwise, we'd have to use the quadratic formula, which we could do, or complete the square. All right, but I bet this is factorable. All right, so how am I going to get 5 cos squared of theta? Can I go 5 cosine of theta times cosine of theta? and then I need a product of -3. So I know what. Can I place a -3 right here and a +1 right here? And I do that because, okay, when I do my outsides and my insides, I've got 5 cos theta times 1 is 5 cos theta, and -3 times cos theta is -3 cos theta, and the sum of those two terms would give me the 2 cos theta right there. So that's perfect. All right, now zero product property of algebra. So this implies cosine of theta would either have to equal 3/5, or cosine of theta would have to equal -1. Okay, so let's find our angles theta. So theta is approximately, well, for this first statement up here, cosine of theta equals 3/5. Can we go inverse cosine of 3/5? So the angle whose cosine is 3/5, and I make sure we're still in degrees. I'm in degrees. Okay, so inverse cosine of 3/5. Second cosine for my inverse cosine of 3 divided by 5. And I'm getting, and does it say what to round to? No. So I'm getting 53.13, something like that. And what did I round to? 53.1. Okay, notice how I brought in the unit circle, because there's going to be another theta that's going to work, but let's put in our 53.1. I don't know, about right in there. How's that look? Not bad. All right, now in what other quadrant will cosine give me a positive output? And that would be quadrant 4. So let's take this terminal ray and reflect it in the x-axis to get that terminal ray. And how am I going to get this one? Well, could I go 360 and then subtract that 53.1? So how about on my calculator, I go 360 minus second answer, my last answer. And that's going to give me a 306.9. Let's see how we did. Haha, there it is, 306.9. Okay, now those are the only two angles in which cosine of theta equals 3/5. So now we have one more angle where cosine of theta equals -1. And that would be, that's a quadrantal angle. When does cosine have an output of -1? Wouldn't this be the terminal ray right there? Yeah, because that distance with direction is -1. And what angle is that? Well, that's 180 degrees. Okay, so there's my 3 answers right now. And we're feeling really good. We did some pretty wild stuff on this problem. Unfortunately, at one point, didn't we square both sides? And let's go way back to first semester. When we're solving an algebraic equation, if we square both sides, doesn't that mean we could possibly have gained a root? So whenever you square both sides of an equation, or you multiply both sides of an equation by an expression with a variable, you've got to check your solutions, because we may have gained a root here. So I'm going to use my calculator to check these. Okay, and again, since we squared the equation, we may have gained a root. So we've got to check all 3 of these and make sure they all work. So first, I'm going to take my original equation, 2 sine of theta equals cosine of theta plus 1, and let's get everything over on the left. So I'm going to say 2 sine of theta minus cosine of theta minus 1 needs to equal 0. Now I just get out my calculator and I'm going to check f of my first answer, 53.1. So on my calculator, I'm going to replace those thetas with the 53.1. So I'm going to go 2 sine of 53.1 minus cosine of 53.1 minus 1. and I should get approximately 0. Now, because that is a rounded solution, it might not be exactly 0. So that's what I just put into my calculator right there, and I'm expecting a number very close to 0. So equals, and yeah, I'm getting negative 0.001 dot dot dot. Negative 0.001 dot dot dot. So that is approximately 0. So that 53.1 is valid. Okay, now let's try the 306.9. Now let me show you a few tricks on your calculator too. Now you can go second entry and just replace those 53.1s with 306.9. So let me delete my 53.1s. And go second, insert 306.9. Close that. Okay. And I don't know, I'm making this a little more complicated, I think, by doing it this way. All right. So again, minus cosine of 306.9, 306 point, and now I've got to insert that 9. All right. And anyway, make sure when you punch this out, this is what you're looking at. 2 times sine of 306.9 minus 3, or excuse me, minus cosine of 306.9 minus 1. And I'm hoping I get approximately 0. Ooh, negative 3.199 dot dot dot. So guess what? That's approximately negative 3.2, and I needed a 0. So that 306.9 is not a valid solution. That is a root that I gained by squaring both sides of the equation above. So that answer does not work. Make sure you do not have that as one of your answers. So now let's check the 180, and again, just change your angles up here to 180. 2 sine of 180 minus cosine of 180 minus 1. All right, and don't we get exact answers? Like, isn't sine of 180 0, and isn't cosine of 180 negative 1? All right, I see what I'm going to get right here. That's going to be exactly 0. Sure enough, exactly 0. So guess what? The 180 worked. So my only 2 solutions for this very complicated equation would be 53.1 degrees and 180 degrees. Okay. So I guess, yeah, some of these are a little more difficult, but man, that's a fun problem. Okay. Now, again, I respect that you guys, you know, this seems kind of easy to some of us, but I know how abstract this can look. And we could answer this question with our calculator. So let's say we weren't up for this. Let's say this is a test and, you know, you've got 10 minutes and this problem to go and you're getting a little paranoid. So how about we use technology? Solve 2 sine of theta equals cosine of theta plus 1. So I'm probably going to do the same thing I did just to check on the previous problem, where I just put everything on one side, all right, and then checked each of the angles I had. So my first step here is I'm going to make sure I'm in the right mode. I'm in degree mode. And then I'm going to put everything over here on the left. So I have y sub 1 equals, and there's a 2 there, 2 sine of x minus cosine of x minus 1. All right, and now let's get a proper window. We might just use a trig window. Let's see. Yeah, it looks like I'm just going to go zoom trig. All right, and when I go zoom trig, here's the window my calculator will give me right here. And now you guys know how to find the zeros on your calculator. All right, you just find these zeros right here. All right, so go second calc and highlight 0 and hit enter, and then you're going to do 1 0 at a time here. All right, and I'll bet you this first one is the 53.1, and I'll bet you this one is my 180 that worked, and then this third one Well, I'll bet you this third one here is beyond 360. Let's find out. Okay, so the first one, and again, to do this, I went, let's make sure I step you through this, okay? I've got that graph, okay, and I'm just going to go second calc 0, okay, like you see above, and then I've got an arrow left or right, so I move my arrow to the left of that 0, and I hit enter. And then I move my arrow to the right of that 0, and I hit enter, and then I hit enter again, and my calculator said that x equals 53.130102 gives me an output of 0. So there's my first answer. All right, then I check this one, and is that my 180? I'll bet it is. And sure enough, I did the same thing. I went second calc 0, and I moved the cursor to the left of that 0, and then I moved the cursor to the right of that 0 and hit enter, and then I hit enter a third time, and my calculator says I've got 180 for a 0. So the 180 degrees worked. All right. Now, if I do this third one over here, that's going to be beyond 360 degrees, you guys. All right. So my two answers that we found by hand, there they are on our calculator. So again, I want you to try to do these problems by hand, but if you hit a wall, use your technology. Learn how to use your calculator too. All right, so I would like you guys to do page 326, 1 through 27 odd. Some of them will be very straightforward and some of them will be a little bit more challenging. Have fun, all right? Take my challenge, do very well. And if you do hit a wall, you can try using your technology or contact me. You all have a great day.